Hello there. Good afternoon, good morning, good evening, wherever you are around the world. I hope we are around here, learn it here in San Francisco. Welcome to our webinar. Welcome to our SQL Server High Availability session that we're starting now. So my name is Armando Lacerda, and it's a pleasure to be here with you guys. Hope you're having a good day. We have 30 to 45 minutes long presentation here now. I would like to share with you on how to implement high availability in SQL Server. I got some slide decks in here I would like to use here. I use these slide decks on my presentation for SQL Pass in Portuguese. It was a Portuguese session. I also speak Portuguese. I'm from Brazil. And I translated this slide to English in order to use it here, but they are gone. I had it on my other laptop there, on my MacBook Pro, actually my MacBook Air, and the battery ran out, and I was in the middle of copying it to the USB drive to connect it here, and the power went out. Things that happens in IT, right? So I'm gonna be doing on-the-fly translations as I move along the slides here, but I do want to use the slides because I have some pictures in there, and the good things, the pictures are universal, right? So it doesn't matter the language they were originally designed. So again, my name is Armando Lacerda. I am a Microsoft certified trainer and also certified in many Microsoft technologies as well, like SQL Server, of course, and Windows and SharePoint and development in C# language in Visual Studio and bunch of other technologies there. And I've been working here with Learnit for about 11 years on and off, actually 12 years, right, on and off. And lately we have been working closer. I've been teaching a lot of SQL Server classes in here. And the idea for this particular session, today's sessions, is about what I have heard from the classroom. You know, when I'm booked here to teach SQL classes, especially the admin ones, I always get questions like, how do we do high availability in SQL Server? What is this always on? And does it support live migration when I'm doing virtualization like VMware or Hyper-V or System Center Virtual Machine Manager and things like that? And I always get these kind of questions in the management or in the admin classes. And this particular topic is not covered there. There is, though, another Microsoft class, Microsoft official curriculum, that covers a lot on this topic. And it's a 5 days one, and I'm also working on a custom one specifically on high availability. I don't have it ready yet. So I decided, I suggest to people here, hey folks, let's go ahead and put up this high availability topic up online. And I know probably some of you are my students. We have been in the classroom together, and you have asked me some questions about this. And I have some demos to show you here how this works, how this is set up. And I hope you enjoyed the session. So let me move over here to the Portuguese. Don't mind the language. I will translate on the fly as we move around here. But let me move it here to the slide deck. As I said, I presented this session on a SQL Pass event. Just some words about SQL Pass. Let me open here a browser here just quick. Yeah, open up here new Edge session. And Edge is not around here, so let me get a new Internet Explorer session and put it in here. Just to get you connected, this is the SQLpass.org. It's a PASS is Professional Association of SQL Server. So it's a free resource for you there, sponsored by Microsoft and a bunch of other companies. And they have these events throughout the year all around the world. And they have this SQL, about the events here. They got this SQL Saturday, and the summit's the only one that's paid though. And they have this 24-hour pass, which is an interesting project. They run sessions, 1-hour sessions for 24 hours. And if you click in here, if you go to their website after this presentation, if you click in here, you can see some previous presentations. My presentation will be there in the Portuguese session they had last year, was at the end of the year, close to the end of the year last year. And yeah, so there we go. I would like you to know that we got a lot of free resources here, great presentations from the big guys, the really real uh, Microsoft influencers, and I'm there too. So let me go back here to the PowerPoint presentation. And so this one here pretty much says high availability. Whoops, that's my mouse here, right? This one pretty much says high, right, edit, there we go. High availability in SQL Server. So that's me, something about me, and this is our discussion today. We're gonna compare high availability against the disaster recover, like the one with my slides, disaster recovery. We're gonna start with this topic here. Actually, and then we go to the principles of high availability, what makes them high availability so distinctive when compared to disaster recovery, and then you're going to see how that works in SQL Server. So let me get that text in here so you can follow along. So disaster recovery, the hallmarks of disaster recovery is based on backup and restore procedures. Backup and restore procedures. The whole idea of disaster recovery is, let me get back here to the camera. So the whole idea of disaster recovery is, okay, my system went down, the building went down, something really bad happened, physically happened to my installations, and I need to get my system back up running someplace. You know, I used to live in Florida, and down there in Florida we have hurricanes almost every year, and actually do have hurricanes going around every year. Some of them hit the city there in Miami, Fort Lauderdale area. And when I was working there for some companies, we had this thing of backing up whatever the resources we need to back up, databases and mailboxes and these things. Put in two medias, in two tapes or two hard drives, and ship one like to Atlanta. We used to ship to Atlanta. We used to ship to somewhere in the central time zone. Because hurricanes, they're kind of a large thing. They can get up to 600 miles, I think. So we have to keep this medias away, really far away. Because there's a disaster recovery when a hurricane goes by, like Andrews, kind of almost 20 years ago or 15 years ago. It was really, really bad. Put down a lot of houses, and you have to keep your copy of your resources physically somewhere else, and because you don't have, for some reason, have lost your processing power. And the thing about disaster recovery and makes the difference between high availability is disaster recovery always implies some downtime. Got that on the slide there, you probably saw that. It always implies some downtime, meaning I will need some time to get my system back up, get some hardware together and restore my data someplace in order to get the systems back running again. And for that, you usually have some SLA, some service level agreement that will be agreed upon, and we have some time frame to put the system back online. So how long is it going to take to get this thing back online? Because disaster recovery implies downtime. Now, we have been doing that in IT field forever, right? Since IT is there, since the first computer went around. We have been doing that, got some downtime, some disaster went by, and we have to put the system back up, so we have to recover from that. High availability, on the other hand, the whole idea is we don't want to have downtime. The main difference between high availability and disaster recovery is we don't want to have downtime. I can afford to have downtime. So I need some other strategy, not backup and restore, to keep my data going on, to keep my data available, specifically to SQL Server, right? I'm going to focus on SQL Server here, specifically to have my data available to the application so I can still sell my products on the internet. People can still collect their data they need to get their work done, and things like that. So the main difference between high availability and disaster recovery is the absence of downtime in high availability. We want to avoid that as much as we can. And in order to avoid downtime, there is one single principle we use in high availability. We get rid, we eliminate all single point of failure elements in the structure of, in our case, SQL Server. Meaning, I always have some redundant copy of any resource. And that's not just the database, not just the data, not just the table, not just the row. That's any element that makes the data flow from the database data file, right? From the database data file on the hard drive, all the way to the network port at the desktop of my user, or the cell phone, the mobile device of the user is using to request the data. So everything in between must be duplicated. I cannot have one single point of failure. And when I do that, the point that it must be understood on this scenario is, when I do that, when I start replicating, making copies of all the resources that are involved in there, I'm always going to have some performance impact. The performance impact on this one is there is an extra control to be done. When the data comes in or is going out, but specifically when the data is coming in, it has to be duplicated someplace. And because it has to be duplicated, it has to be controlled, make sure there is no shadow things going on someplace that will disturb my data, and other effects like that. So there is always some performance impact. Usually they are light, but we have to account for those, right? But again, as I said, with the goal here is to not to have any downtime. So in the next slide here, this one here, so the high availability, let me put this one here. So the high availability principles, things we must have in place if you want to make sure we have high availability, is, as I said, no single point of failures. And another important element when implementing high availability is automatic switch or crossover, right? So the idea here of the automatic switch or the crossover is, when my system fails, I don't want to disturb my line of business applications. Meaning, if my database, my server goes down somehow, for some reason, I don't want the client application, the end user application, to feel that they have been disconnected, or they are not able to connect back to the source of the data they're looking for. When one of my servers goes down, I need the other one to pick up automatically, no human intervention. Because if I have some human intervention, I'm having downtime. And again, the goal is not to have downtime. So the crossover, the switch in between the main resource and the backup resource must be automatic, right? That's one of the hallmarks of high availability. So hallmark number one, no single point of failure. Hallmark number two, automatic switch. And when doing an automatic switch, that moving over, right, the crossover in between one system and the other must be automatic, of course. And another thing that's very, very important to keep in mind here is we're going to have data duplication. If my data is running in one processing unit, like one SQL server, and I'm going to move to another SQL server when processing, the data must be duplicated somewhere. And if I decide to use Windows clustering, clustering based on Windows operating system, usually the data is replicated within the SAN and the remote storage, but it is duplicated over there to guarantee high availability and no single point of failure, or some other place, depending on the technology I use. But there's always data duplication. My data will be at two places at the same time. And when doing this, what's the method that I would be using? What's the method I want to use? And the recommendation, if you research this around, because high availability exists not just for SQL Server, it exists for many other technologies, and has a principle: the data should be replicated in small single blocks. It should be distributed in small single blocks and as much as possible not accumulated. And that's a big deal when choosing out-of-the-box SQL Server high availability options, because SQL Server has been around for a while and we have a lot of high availability options in SQL Server. So here we go. Let me show you this picture here so we can discuss based on top of this. Servers going on over there, and there is some dedicated network to get these servers connected to the remote storage. So this basically, standard Windows cluster implementation. By the way, the new versions of Windows servers also give you an option to do it without a remote SAN. There is another option of doing that in new technology, new SQL Server implementations that really look a lot like SQL Server approach, but we're gonna see, you can check that later. But again, as I said, the traditional one is 2 servers and redundant network connectivity between these servers and the remote storage. Of course, really high speed and some sort of a heartbeat going on here in between these 2 servers, so they can check each other if they're both running, and if they're not running, if the active one fails, the standby one takes over, right? And SQL Server is somewhat oblivious to this. We don't install SQL Server when we do this particular approach here. We don't install SQL Server in the regular way. We install SQL Server using the SQL Server installation software, but we use a particular option in there to tell SQL Server that is going to be part of a cluster, right? It's going to be presented to the cluster environment, and it's going to be a service in the cluster, and it will show up like this little screenshot here is showing us. It comes as a resource of the Windows cluster service, and we do all the management about the cluster high availability and the switch over in between nodes from this guy here. All management is done from this guy here. In SQL Server, in Management Studio, is pretty much just the tables, just the data in there. As I said, this is the most common implementation we see out there. But there are some issues with this particular one here. Not technical issues. It works great, right? Of course, it's very reliable. Everyone is using this since day one. Although in the beginning it was a little complicated to get this thing working because the hardware compliance, requisites they were very strict, and we have to work with the same manufacturer, the same network card. And a lot of things has to be really compliant with clustering. Nowadays it's easier. Nowadays it's way more flexible. We have seen Windows supporting distinct servers on distinct processing power with distinct vendors and even distinct network cards. It has become way more flexible, right? Way more broader in terms of hardware support, but still we have some issues on these ones here and this particular approach. And what are the issues? These ones in here. Kind of try to summarize it here. The first one is in SQL Server, when we use high availability in Windows, right? Windows cluster high availability SQL Server high availability. When we do this in Windows cluster, we can't have active support for SQL Server instance. We cannot have active support in SQL Server. If you go around and Google this, you're gonna see some people there on the internet talking like, oh, come on, if we use Windows cluster servers, you can have an active implementation of SQL Server, and that's just not true. I was actually take some sessions with Paul Randall and online, and he was talking about like you cannot imagine. It's really amazing the amount of misconceptions and myths we have out there around SQL Server in many aspects of SQL Server, and this is one of them. In clustering, if you decide to go for Windows clustering, you're never going to have active SQL Server implementations running on your network, right, on your data center. What happens is this: you're always going to have an active. See, this one here in bold is my active instance in one server, and that particular instance, that particular SQL Server resource or installation will be passive everywhere else. So that particular database, or the collection of databases supported by instance 1 will be always supported by these guys here, by this guy here, while it is alive. Now, if this guy goes down, this particular server here goes down, then the next instance, the copy instance will come live. But you see, it's always active, passive. And what some people do is they go like, okay, so this is active, passive, but if I do a second SQL Server installation or a second instance and get that second instance running on the passive node of instance 1, then I have active. And you can see that, right? You can see that. It's kind of cheating, right? We can see that on a diagram, because you have two SQL Server installations. They are running twice. Depending on how you go on license, this will get even more expensive, because this kind of implementation is already expensive. You need enterprise and so on. So yeah, Windows cluster is the common one, but has this problem with active-passive implementation. You cannot have active in SQL Server. Some other slides, I will make this, as I told you, I have this slide deck in English already on the laptop that's out of juice over there. But when we finish this, I'm gonna make the other slide deck available for you, right? Just shoot me an email at the end and I'll send it to you. So yeah, so that's the problem with high availability when we do Windows cluster service. Now we are talking about in Windows installation, within the Windows installation, right? In high availability, we use a Windows cluster service. Now, when we look into virtualization, and I don't have any slide about virtualization here, because it's really not within this particular approach we're taking here in this session. When we think about, hey, can we do live migration, right? Either using VMware or Hyper-V when I virtualize my SQL Server. Yeah, you can. You can do high availability based on virtualization. Definitely you can. But again, that's outside. Windows is completely oblivious to that within the virtual machine. And SQL Server doesn't know a bit about it, right? Doesn't know anything about it. So you're completely dependent on the reliability of your infrastructure, of your virtualization infrastructure. You can use that, of course, you can use that. But I'm not going to go into there because, again, it's even outside the operating system by itself, right? It's the hypervisor and how you manage the hypervisor among your servers. So within the operating system, right, still back into Windows and look into SQL Server, if we decide not to use SQL Server, Windows Cluster Service, we do have some options in SQL. This slide here, let me show you it in here. It shows you the names are in English, most of them. So this one is database replication and mirror and always on. There we go. So we have these 4 options out of the box here in SQL Server. We get very old standard one. I don't even classify myself as high availability, but it's it's there on the list if you look for Microsoft documentation, official ones. So get the standby server, we get the database replication, we get the mirror that came along with SQL Server 2008 and is the the parent or the grandfather of always on and always on availability group. So we have these 4 options in here. Let's go through them just quick, and we go into the virtual machine to see how always on can be set up in SQL Server. So here we go. The first one, standby, right? So let me take this Portuguese thing out of here. Let's go for the standby server. What's the idea of a standby server? That was all the way back in SQL Server 6.5, very, very old approach. And the idea is okay, you do have a backup schedule, right? You do have a backup routine you do every day on your company. So you could use your backup files restore those backup files in another server, and make that server like your standby server. So if something goes bad with your primary server, you can get that standby server going on in a relatively short period of time, right? If you compare to disaster recovery, and your clients will have to connect to this new guy here. As I told you, this is a very, very old approach. I don't recommend it anymore. I would say it's not recommended. I don't recommend it anymore because it fails in a lot of prerequisites for high availability. One is there is a downtime in this one here, right? Because if this guy is live, the green one here is live and the red one here is down. So if the red one is standby, when the green one goes down, like this. Let me see here. I got some artistic thinking here. Oh, this is one picture. Forget it. So if the green one goes down, someone will have to manually go into the standby server, see if you have the latest copies of the transaction log to restore it there, and then make it live available for read and write. And then go in your infrastructure, in your DNS elements, and make the names pointing to this server here instead of the green one. So it's very manual. There is a downtime involved in here, and there is always some loss of data on this one. You don't hear much about this guy anymore, but it's still an option in SQL Server. If you have other implementations, you may see people using this one here. Highly not recommended in my sense. The other one is based on database replication. And I had a student a couple of weeks ago, database replication. I had a student a couple weeks ago who was asking me about that. I hope she's connected in here. And on this particular one here, what happens in here is not actually high availability. Although if you look into TechNet and MSDN and you look for some documentation in there, you will find some documentation saying that this replication thing was designed for, can be used actually for high availability. It was never designed for high availability. It pretty much doesn't comply to anything in terms of high availability. And the important thing to keep in mind here is database replication is based on schema, meaning you pick and choose which tables, and even from the tables, which columns from the tables you want to get copied over from the source into the destination. The idea of database replication was to make copies of data from a location to another location, because the network connectivity there was sort of slow. 20 years ago was sort of slow, and you couldn't keep the applications on the remote location connected to the the headquarters, for instance, collect the data all the time from there. Nowadays it's even difficult to envision this kind of approach, because we live in the cloud era, right? Our data is in the cloud all the time, and we are always dependent on being online all the time. So this kind of implementation uses high availability based on database replication. To me, it kind of sounds like a misconception, but you do see these things going on. So, just to give you a brief idea, so you get the live database, your publisher database in here, and your copy that's distributed to another server, some other place, which is the subscriber. As you can see, they even use a particular terminology of them, right? It's based on publisher, distributor, subscriber. It's kind of a magazine thing. And what happens is data modifications coming from the publisher, only the ones that I select, are copied into a distribution database, and from there copied over to all the subscribers. So this is definitely not high availability, and incurring a lot of overhead. You do have to have space for this guy here. The transaction logging here really usually runs crazy, because you have to keep accumulating the transaction log because the distribution database gets the new data from the transaction log, not from the underlying data files, and then send that distribution over to the subscribers. And there are a lot, you see these little rectangles here, the log reader and the distribution agent. These are processes running on usually on the distributor. Could also the agent could also be running on the subscriber. And if this process for whatever reason they stop working, your replication stop working as well, and you start accumulating data waiting to be replicated to the target destination. So my recommendation is don't even think about database replication for high availability, or even to get data available for load balancing, right? If you have a highly intense transaction-based system going on here, a lot of transactions, data modifications going on, and you need to get reports done all the time from the subscriber, from a copy, right? Don't even think about this in here, right? This is really not designed for that. Can be used for that, but it's not really designed for that. Oops, sorry here, my mouse. And in SQL Server 2008, we got this mirror, right? This is SQL 2008 mirror. That was the first time we have seen something different coming into SQL Server on the SQL Server level for database replication or database high availability, not relying on the operating system. And the idea here is I have a server. I have actually two servers, as you can see, a principal and a mirror. And everybody connects to the principal, and you see the data is in the server. It's not a remote location like a SAN, like would be in a cluster. And the data is copied over to the mirror. And if something goes bad to the principal server, there is a witness. There can't be a witness, a SQL Server witness service going on somewhere else in another computer. And kind of cheap on this one here because we really don't need extra license for that, right? You can run even a SQL Server Express, making sure that this guy is up. And if this guy here goes down, this guy here, the witness server, it will sense that and will tell the mirror server to assume responsibilities for the database, right? To bring its copy as available for read and write for transactions. And client applications, they can start connecting over here instead of connecting in the principal. So the switch over was automatic for the new server, but the client application connecting to SQL Server would have to use specific settings to understand if this server goes down, go to the other one, right? That was the one of the limitations this one on the mirror, on the SQL Server Mirror. Another limitation on the SQL Server Mirror back in 2008 is it was limited to 2 nodes only, right? You could not have 3, 4 servers like we can have today in SQL Server 2012 and SQL Server 2016 that was released just yesterday. And I just made my first production installation yesterday. Yesterday. So we can have even more servers involved in the replication of the data. But again, in SQL Server 2008, in Mirror, only 2 nodes, and that was one of the limitations. That's why we don't use this anymore. Microsoft has already published, Mirror is deprecated, and you should not consider using Mirror anymore. But some people use SQL Server 2008 yet, so just to share that with you. The good one is this guy here, right? The always on. This is our topic of interest here. This is the one we want to implement. SQL 2012, always on, right? And the idea of always on is, like in the other ones, I have a primary server, principal, the live copy that all my client applications are connecting to it and making changes to it. And when I enabled always on, this server here will send copies of the data to other servers. And what's important to realize in here is when this data is being copied to the other servers, the transaction log is involved, of course, but there is my selection is on the database, on all the elements in the database, not just a couple of tables and a few columns on those tables if I want to get granular to the column level, but there is no option for that. What is copied in between one server and the other server is every single data modification that happens on the primary server. They get replicated to the mirror server, right, to the copy. And the idea here, I need you to really understand this, right? To get a grasp of this is the idea here. It happens at the page level. It's per transaction, of course, but it's at the page level. So when a dirty page goes into the buffer, right? When a page is changed in the buffer, that the data page that has been changed will be copied over to the target servers, to the mirror servers. So it's highly dependable. You know, the granular level is the smallest it can be. So you don't have to accumulate much if you don't want to. There is no scheduling for this thing. It happens on the fly. Has the transactions happen in the primary server. And another benefit of this, let me go back there to the slides. Another benefit of this one here is these guys here. Let me get this guy off. I don't want you to be distracted by these Portuguese things. And once again, guys, I apologize for not getting the slide deck here copied on time. But anyways, you see, these guys here, these clients here, are my point of sales on my store, or my website that's doing e-commerce and collecting all the transactions, all the products my customers want to buy from my company. So this is read-write. You see, that's read-write. When these changes, they come into the server, specifically the right ones, the changes, those changes are copied, like I just mentioned, to the other servers. They're copied over here. We can, in Always On, get some of these servers to make them readable. And we can configure applications, the applications that our developers use or we buy from vendors. We can configure these applications depending on the kind of clients they use to connect to SQL Server. To report that to SQL Server, hey, I'm connecting just for reading. I'm not connecting to read and write, it's just for reading. And there will be common name to all of these servers in here. And if the client application says it's only for read, like I just want to print reports out of this, is a report service installation, or a SharePoint website that's just reading data from the database, not writing back any changes. The SQL Server itself understands that and connects those servers to the copies, not to the live transaction data automatically. I don't have to do anything. It's the same configuration. It just says that on the connection string that this thing here, this server here will connect for read only, read intentions, just for read intention. And with that, I have load balance. You see, we achieved, with this particular setup here, we achieved the best of both worlds. I invested money in many servers, but the other servers, the copy servers, they are not idle like they would be in a cluster, right? They are doing something for the overall computing needs of the company. They are serving data for reporting, for consulting, for people in order to people to query the data, and that's one of the greatest benefit of this. Always On, it also supports dispersed geographically data distribution. So I could, one of those 4 servers I have there in the slide, one could be here in another room, right? Using another electrical installation there just to have redundancy. It could be there in another room, and I could have 2 other ones some other place around the world, here in the country or around the world, and replicate into all of them. And make all of them readable for the local clients where they are. And if something goes bad in here, I may want to switch to the one that's local here, the copy in another room. Or if my whole building goes down for some reason, I can switch over automatically to the other guys in the remote locations. And of course, if the building went down, my local clients here will not be able to connect, right? The whole building went down. But the other clients, they are live, up and running, right? Because of Always On distribution. So Always On should be considered as the current option for both high availability and distribution, workload distribution, load balancing. Is the best implementation of all of them. So to wrap this up, let me go back here to the virtual machine. Actually, I'm going to start the virtual machine. Before I go there, also noticing here that the data, you see, is is stored locally on the server. It's not using a central location like it was using on a cluster, right? When you do in a cluster, that's, usually gets you have to invest a lot of money here. It's not on a remote location, on a network drive, like on a sandbox someplace in my local network, in my local data center. So the SQL Server data is actually stored on, in the server, in the actual box there, on the same hardware, and it's copied over to other hard drives in the other servers. So I have also not just, eliminating a single point of failure. That's my point. Eliminating a single point of failure that would be the SAN if the SAN goes down. Although it's kind of rare, they're very reliable technology resources, but can happen. It's a single point of failure anyways. So here on the virtual machine, whoops, got disconnected. Let me connect again. By the way, in terms of license, since SQL Server 2014, you can do always on with 2 servers only, right? In SQL Server 2012, we did not have this option. We have Mirror for 2 servers only, or if you want to use always on, you have to go to the enterprise license of always on. In SQL Server 2014, and also in 2016 now, we can have always on for 2 computers only on the standard edition, right? It's a way cheaper license model than the enterprise one. So if I don't need 4 copies, the primary one and the other 3 running somewhere else, if 2 is good enough for me, I can have that available. I can implement that with standard edition of SQL Server 2014 or 2016. So more likely you have this available for you now, right, with your license, and you can try this out. And talking about try this out, back here in the virtual machine, this is one of the virtual machine we use in classroom here. And you can see behind me, I actually cannot see anymore, but behind me here is the main street, Market Street here in San Francisco, so sometimes you got this sirens going off. So in any case, this is the resource we use in the classroom here at Learn It when we are teaching SQL Server. So in case you decide to get some hands-on training on this, you'll be using exactly what I'm using here. And let me show you here that I have a few servers in here. Let me see here, SQL Configuration Manager, SQL Server Configuration Manager. Come on. And of course, these guys, they have some code going on in there, and it's like when it's a structure doing a presentation, you fail, you go slow or something like that. But here we are. We got here our SQL service, and I got SQL Server going on in here, and it seems I'm not running. Oh, there we go. We got this SQL Server going on in here, right, on this particular machine, and I have other servers going on here as well, right? I get cluster 1, the other node is going to be cluster 2, and the other node that's going to be cluster 3, right? So I got these 3 guys going on in here, and the idea is to make them high available. And there, here we go, right? Here in the always on, we can create the connectivity settings to have these guys working together. Now, one thing I would like you to be clear on is, for always on to be available, for always on to work for SQL Server, in the Windows resources in the Configuration Manager, we have to install the cluster service, have to enable it. So let's go here to add roles. Let me show you that. I think it's already here. Role based on my server. File and storage service. So I got the storage service going on in here, and my cluster. Let me double check here. Cluster. Failover cluster manager. My cluster is available there. Let's wait for it to show up. There we go. So my cluster is available in there. But notice that there is no resource on a cluster service. There's nothing presented in here. There's absolutely no resource going on, right? The cluster is there, is installed. Doesn't even have to be enabled. It's just there installed. And the reason for this guy here is for SQL Server to replicate the transactions that are going on in between SQL Server and the clients and to the remote client. SQL Server use some of the cluster resources in cluster resources. What I mean is actually the cluster code, right? It's not resource like, you know, a data storage or something like that. It's just the DLLs, you know, it's just the code that goes in the Windows cluster. So instead of re-implementing the code twice, they were smart and they're just making calls to common codes that are needed for both places. So that's a great thing that I think Microsoft designed for high availability. So in here, I can go ahead and start using the wizard, right, to get the cluster, the high availability going on. So the group in here is going to be, you know, simple demo. And don't have any database in here. Oops, sorry. Let me double check this. Oh, look at that, no database there. So let me add some database to this. D file, demos, module 8, and let's get this guy in here going. Restore this database there so we can see some database going on. All right. So while it's doing, okay, database is there. Let's do a refresh here. I should have something in here. There we go. So I have demo 1 and demo 2. Now I got 2 databases in there. Let's go back here to the wizard. And again, simple demo. As I told you, high availability in SQL Server is based on the database, right? It's not based on the objects in the database. It's all the database, is the whole database at once, right? And the idea of doing this is you're not dependent on the instance, right? You really don't have the configurations of for the instance are not required to have the database going on. But again, it's important to keep that in mind, because when you do live migration, you use virtualization technology, all the databases on a particular instance are migrated over, right, when the virtual machine moves on. And this one here, I can have a better distribution because I can get distinct servers doing the supporting the replication for distinct databases on the primary server. So I can even get a scenario like that. You know, you can have a main server that's really robust, and you can have like 4 other servers that small footprint servers, cheaper servers, and each one of them could have one or a few, not the whole copies of the other databases there. So as you could see, I have to take a backup here, right? I thought that this backup was already there. I think I have reset this virtual machine before this presentation. So that's the database I want to get it to, and I want to implement automatic on this guy here, and I have to create the endpoints in order to have this guy communicating to the other servers in there. Where's the backup? So where I can get the information coming up, and the listeners, who is going to be the listener for this always on implementation. So my time is running over, right? It's about, well, look, we have together here for about an hour. But as you can see, you can go with this in using Wizard, and you can get it really up and running using a Wizard. And just to kind of finalize this one here, I'm gonna connect to SQL cluster 2 in there. So this is my secondary one, and the failover also automatic for this guy here. So it's a synchronous communication. You see the replication of the data in between the servers can be either synchronous or asynchronous, and that the synchronous one is the one that guarantees you never lose any data in case of a in case of a failure. If you make it asynchronous, you can come to lose some data depending on the delay, how slow is your network. So you can get to some loss of data in there, but you always need a synchronous one. And as I told you before, we can make one of these copies readable or read only, right? And even mark it as read intent only. As I told you, when client applications come in, they say, hey, I want to connect to this database, but my intention is only to read, not to write anything back. This is kind of the reporting service idea. And when I do this, I have load balancing going on, all right? So with that, I would like to open for questions, right, guys? There on your Google presentation there, you have an option there for chat, for questions. If you have any questions, that would be a good time. We have just 4 minutes left in here, and let me see if anything goes on in here for questions. Let me take a look. I don't see anything coming in yet. Nope. Here in the chat window, it's kind of quiet. So if you have any questions, guys, you let me know, right? You can also email me. Let me go back here to my slide deck to get here my contact information. There we go. Here we are. And let me erase this and switch back in here. So you can get in contact, right? To get my Facebook's more kind of personal things, but I do some posts on LinkedIn, and I do tweet from time to time too. And the email you can use to contact me is alacerda@learnit.com here on the slide deck, right? So with that, I hope you have enjoyed our time together here. I hope we have learned a little bit about the options we have for high availability in SQL Server. And enjoy the rest of your day, wherever you are connecting from. And I see you next time.